Hello all of you. So welcome to this amazing session of friction. In this beautiful session we are going to talk everything related to friction, guys, and like I'll cover all possible theory that you can think of in this session, and we will do lots and lots of PYQs so that you get practice on the real sets of questions that has already been asked. So why are we waiting? Let's start. Okay, acha, before we start, let me also quickly tell you that why should we study this chapter. Okay, see, not that the question from this chapter cannot come. Of course, as you would see today itself that there have been lots of questions from this particular chapter in JEE Mains and Advanced both, but this topic is also required in other chapters of physics that we are going to talk about in the future. That means the concepts that we are going to study in today's session will be required in today's chapter in this session, like in this chapter as it is, but in the chapters that are going to come in future, like center of mass, like work per energy, rotational motion, or like any other particular chapter in physics, so the concepts that you are going to study over here will be required. Okay, so that makes this particular thing makes this chapter super important. Okay, so let's start, guys. Okay, so we are talking about friction. Okay, now what is friction? First of all, you can see this handsome man sweating it out in scorching heat. Okay, so he's trying to pull this block. Okay, he's trying to pull this block, but why do you think that he has to apply so much force? Okay, but you can see this sweat also coming, this green colored sweat coming out of this person, but why do you think that he has to apply so much force? Of course, because as he tries to pull this heavy box on the ground, there is this force which is trying to resist the motion. Okay, which is trying to resist the motion. Okay, so let me put it in a better way, which is trying to resist the relative motion. Okay, but since the ground is at rest, so we can say that relative motion in this case will be can be called as motion itself. Okay, in reality, friction opposes relative motion, as we would see very shortly. So guys, what is friction? You can see there is a parallel force between these two surfaces. One surface is this and one other surface is the ground. So this surface, so this force which is parallel. Okay, so like there are two surfaces in contact. You can see one is ground and other is the bottom of the block. So the parallel force, the force which is existing parallel to these two surfaces is called friction. There is one more force between these two surfaces. Can you name it? Think. Can you name it? Yes, it's called normal reaction. Okay, so if you thought it, great. So guys, what is friction? Friction is a parallel force. Friction is a parallel force which exists between two surfaces in contact. Okay, so it's a very simple. Trust me, it's very easy chapter. Okay, some might think that it's a difficult chapter. Not at all, it's very easy chapter. Okay, so what is friction? Friction is a parallel force between two surfaces in contact. Okay, the perpendicular force is called normal reaction, that you have already seen in the laws of motion. Okay, so let me quickly tell you. For example, suppose this is a ground and this is a block. Okay, this is a block. Okay, so suppose this is being pulled by some external man. So you can imagine that this man is trying to pull the block. So you can assume that if this person is trying to apply force F and this is block M kept on the ground. Okay, so basically this mg will act down. This is the force applied by the earth on the block. Okay, and there are two forces we can say which ground applies on this block. So in reality, ground is applying only one force, but the normal component or the perpendicular component of that force is called as normal reaction. So this component, or we can say that the force that is applied in this direction is called as normal reaction. Okay, so we have already seen this, and there will be one more force which is trying to resist the motion, and this force we are going to talk about in today's session, which is called as friction. Okay, so friction always opposes relative motion. We will talk about this very shortly. Okay, there might be motion or there might not be a motion. I mean, block may or may not move. Okay, it's not a necessity that this person will be able to move this block. Think of yourself and think of this as a 100 kg a stone. Okay, so will you be able to move it? I cannot move it. So okay, I don't have so much of strength. So this block may or may not move. Even if it moves, then also friction will be in the leftward direction. Even if it does not move, then also friction will be in the leftward direction. So in both the cases, friction is trying to resist the motion. If the motion is happening, then also friction is saying no, don't move. If the motion is not happening, then also it is not happening because of friction. If there was no friction, then this person would have moved this block very easily. Think if we just sprinkle lot of powder on this surface, then this person will be able to easily move the block, right? So basically friction opposes relative motion. So now so that is exactly what I told you. Friction opposes relative motion between the two surfaces in contact. So here you can see that this black man is trying to push this block, although the motion is happening in this case, but friction is actually will be acting in the leftward direction. Okay, friction will be acting in the leftward direction because friction always opposes relative motion. Now why am I saying relative motion many times? Very simple. See, when like the friction always tries to like resist the relative sloping. That means with respect to ground, if the block is trying to move in the forward direction, with respect to ground, if the block is trying to move in the forward direction, then friction will say no, don't move. Okay, although here the ground is at rest, so we can say relative motion is same as motion. Okay, but if the ground itself was moving, okay, suppose my hand, suppose I keep the remote on my hand, can you see this? So if my hand is moving in the forward direction, so I would want to see the velocity of the remote with respect to my hand. Very simple concept is that, like, you should always try to see the velocity or the motion in the frame of the surface on which the block is kept. Very simple. Okay, so here the block was kept on the ground, and ground is at rest, so we can say like the relative motion itself is the motion in this case. We will talk about other cases where the ground will, like the surface will be moving, so not an issue. As of now, just understand that friction opposes relative motion. Okay, so what if friction is not there, guys? What happens if it's like many of you think that friction is bad. Okay, okay, this is not the case, guys. In fact, friction is very, very important in our life. Okay, in fact, you might have heard a situation, or you might have heard about a very famous statement that friction is necessary evil. Friction is a necessary evil. That means that friction is evil, but it is a very necessary evil. It is very important part of our life. Okay, so basically friction is not present, then you can see this cute little puppy is not able to stop on the ice surface. Okay, so like he is struggling to stop because he was walking at a very fast pace, and then he wanted to stop, but friction is not there, so he's not able to stop. So in fact, like if we assume friction to be zero, then this cute little puppy will not be able to stop only. Okay, then you can see this is snake. Okay, so you might be feeling slightly scared. So why is this snake not able to move in the forward direction? Do you think? Like, can you think? So basically this snake is just shaking like a sine wave. It is not able to move in the forward direction because the surface on which it is trying to move is very, very smooth. So basically, for moving in the forward direction, there should be a friction. So if a snake is, see, in this case, if a snake is right in front of you and it is on the smooth surface, then it will not be able to bite you. Okay, so in this case, absence of friction can save your life, because friction, snake is not going to, will not be able to move in the forward direction, because surface is so smooth that friction is not snake is not able to generate friction, and it is not able to move in the forward direction. Okay, so friction is required for walking as well. Okay, now that is why I was saying it is a very, very important part of our life. It is a necessary evil. Why do you think that we need friction to walk? Okay, try walking on a ice. So your situation will also be like this cute puppy. Okay, you will not be able to, you will slip so much. Okay, or try walking on a surface on which lot of powder has been sprinkled. Okay, you will struggle really badly. Okay, so why? Because friction is very, very less on such a surface, and in that case, we can say that since friction is not present or very less, so we will really struggle in walking. Okay, so but why at all friction is required in walking? So try to think carefully, how do you walk? Okay, I mean, you might be thinking that now, sir, don't ask me that how do we walk. Of course we know how to walk, but try to think, try to understand the physics behind that. If you keep your like one foot, suppose see me, okay, although you can just see the top half of my body, but imagine I have kept my left foot forward. Now what I will do to move in front, I will try to push the ground in the backward direction. And in turn, by Newton's third law, ground will actually push me in the forward direction. Okay, try to think. Suppose okay, this is the lady. Okay, so see how she is walking. Let's look at this fit. So I'm drawing her fit. Okay, this is one foot. Okay, so this is 1 foot. So she suppose she has kept her foot on the ground. So what will she do? She will try to push the ground in the backward direction. So by third law, we can say that ground will apply the friction in the forward direction. So many of you might think that ground applies the friction on the backward direction. This is wrong. Ground applies the friction in the forward direction. That is why you can move in the forward direction. Arey, you are moving in the forward direction. How come? Because of friction only. So friction is not acting on the backward direction. Friction is acting in the forward direction. Why? Think carefully. Because the lady was trying to drag her feet in the backward direction. Try to think, how do you walk? You put your left foot on the ground and try to push, try to drag your foot in the backward direction, but your foot doesn't drag because relative slipping is not happening and the ground pushes you in the forward direction. So guys, friction acts in the forward direction on the foot of the lady. Okay, this is slightly complicated, don't worry about that, but try to understand that friction is very important for us to walk, because you know that without this friction you won't be able to walk. You understand that, right? So now all of you would agree that friction is not that big and evil as we might think. It's very important part of our life. Okay, now what are the types of friction? So basically there are two types of frictions. Okay, one is static friction, okay, and other is kinetic friction. Okay, one is static friction and other is kinetic friction, right? Now let's see both the cases of frictions one by one. Okay, so some of you might have read that there is also limiting friction, rolling friction. See, it is not correct. Limiting friction is nothing but the maximum value of static friction, and rolling friction is not a new type of friction. It is nothing but static friction only. So when we will see rotational motion, you will get to understand that rolling friction is nothing but static friction only. That means there the point of contact, the surfaces of contact has become so small that we call it rolling, but actually it is static friction only. So we'll talk about that in rotational motion, but try to understand that there are only two types of friction, static and kinetic. Okay, now what is static friction? So guys, when the two surfaces are not slipping on each other, try to see this black man. He's trying to push this block with all his might. So FA is what? Force applied. FA is what? Force applied by this black man. And what is FF? Force of friction. So force of friction will be generated here. Okay, this is the force of friction. Okay, and FA is the force applied by this black man. So try to see what is happening over here. What is this diagram telling you? He's trying to push the block with all his might, but is the block moving? No, block is not moving. Why? Because see, both this blue and green vectors are of equal length. That means if he applies 10 Newton force, friction becomes 10 Newton. If he applies 20 Newton force, friction becomes 20. That means if he is increasing the value of applied force, try to think, if he is increasing the value of the applied force, friction from the ground is also increasing in the equal amount. So basically what is happening? So if he increases this force F, friction from the ground is also increasing. Okay, and such that block does not slide. block does not slide on the ground. Okay, so guys, this type of friction is called as static friction. Very, very important. When the two surfaces are not sliding, can you see that bottom of the block is not sliding on the ground, it is stationary on the ground, it is not sliding. So in such a case, it is not slipping on the ground. Okay, slipping, the keyword, the very important word is slipping. Okay, there is no slipping between the block and the ground. So we can say that here the friction is called as static friction. Okay, here the friction is called as static friction. See my hand, see, look at my hand. Remote is kept on my hand. Okay, now I am moving my hand. What do you see? Can you see remote moving between, can you see the slipping happening between my hand and remote? Do you see that slipping happening? No. Remote is moving, my hand is moving, but slipping is not happening. So sir, when will slipping happen? See, now slipping is happening. Can you see that? Now remote is slipping on my hand. So guys, this kind of situation, what type of friction? Static. Okay, because remote is not slipping. This type of situation, when you can see that, you can also hear the sound, I guess. So this is the kinetic friction. Okay, so let's focus on static friction first. So when there is no slipping, in that case friction is called as static. Okay, in that case friction is called as static. Okay, please do not confuse it with the motion. Okay, see this example again. Here remote was moving, yes or no? Yes, remote was moving. What kind of friction? Static. What kind of friction? Static, because slipping is absent. Slipping means sliding on my hand, so that is absent. Now this is kinetic friction. Okay, so I hope you have gotten the clarity. So I hope you have understood static friction. What is static friction? When there is no slipping between the two surfaces, then the friction is called as static in nature. I hope you have understood. Okay, now how to find the value of the static friction? See, static friction is self-adjusting. What does this mean? See, it means that this black man, he applies force, static friction increases. He applies more force, static friction increases more. That means the moment he is applying bigger and bigger value of the force, static friction is increasing bigger. That means it is adjusting its value. It do not want slipping to happen. It does not want slipping to happen at any cost. Okay, that is why it is increasing its value. Okay, but can it keep on increasing its value? Suppose instead of this person, you call the most powerful person. Okay, who is the most powerful person? Not Narendra Modi. He is powerful politically, but let's talk who has got more strength. Maybe Bahubali. Okay, Bahubali has got a lot of power. Okay, yes, so let's call Bahubali. So if Bahubali starts applying force, okay, let's call Bahubali. So if Bahubali starts applying the force, will the block move? Yes, it might move. Okay, that means, what do you understand? That means static friction cannot increase its value all the time. That means it can increase its value up to a certain limit. That means it can increase its value up till a certain value. Okay, it cannot increase its value indefinitely. So my dear friends, that certain limit is called as limiting friction. So guys, what is limiting friction? Limiting friction is the maximum possible value of static friction. Please understand this statement, very important. Limiting friction is the maximum possible value of static friction. Maximum possible value of static friction is called as limiting friction. And what is that value? Mu s into n. I will talk about mu s very shortly. N is normal reaction here. So guys, please understand, what is the maximum possible value of static friction? Mu s into n. So what do you understand from this discussion which I had just with you? That means static friction will keep on increasing its value if the requirement is, if the boy increases the force, static friction increases. Boy increases further, static friction increases further. Boy increases further, static friction increases further. Now Bahubali comes. Bahubali starts applying the force. Static friction cannot increase beyond a certain value. So that maximum value up till which static friction can increase is called as limiting friction. Okay, so limiting friction is not a new type of friction, my dear friends. It's the value which is till which the static friction can increase. Okay, and what is that value? That is called mu s into n. And you know that is normal reaction. Now what is this mu s? Mu s is called as coefficient of static friction. Okay, mu s is called as coefficient of static friction. So this is mu s is called as coefficient of static friction. Okay, coefficient of static friction, right? Now guys, what do you understand by mu s, or we can say how to interpret mu s? Okay, we understood that mu s is called as coefficient of static friction, but what is the feel of it? Okay, how to analyze that? What does it want to tell you? Basically it tells you that degree of friction available, or we can say that degree of roughness. Not exactly roughness, but try to think that if mu s will be more, then friction will be more. Okay, that means we can say that available friction will be more. That means if mu s will be more, then if mu s is very, very high, then even Bahubali cannot move. Even Bahubali cannot move the block. Okay, that means basically mu s is the degree of roughness. I mean, not exactly, but just try to think in that term, that mu s is trying to tell you that it is very difficult. If mu s is very, very high, then you know available friction is very, very high. That means maximum value of static friction, the maximum value up till which the static friction can increase, that value is also very, very high. Okay, so that means it will be very, very difficult to move. If you sprinkle powder, or if you know on the ice, mu s will be very less. Okay, so that means available friction, or we can say maximum value of static friction, is very, very less. I hope guys you have understood. Okay, so I hope you are clear till here. So I hope you have understood. Static friction can increase its value from 0 up till how much? Mu s into n. And generally you will see that mu s lies between 0 to 1, but it is not a rule. Mu s can be greater than 1 as well. Okay, nobody is saying that mu s has to be less than 1. Mu s can be greater than 1, but yes, in most of the questions that you will see, mu s generally lies between 0 to 1, but again it's not a hard and fast rule. Okay, so what did you understand from this, guys? That static friction can lie between 0 to mu s into n. If the requirement is there, then it can increase its value up till mu s into n. So you can see this boy applies the force, friction increases, boy applies more, friction increases, but till what value friction can increase? Mu s into n. Okay, so I hope you have understood. Now what is kinetic friction? Kinetic friction is very easy. Okay, kinetic friction is when slipping happens. Okay, you can see now the remote is slipping on my hand, so you can see that now Bahubali has come. So this black man is able to move the block. So now you can see that this friction that is occurring between the two surfaces, that means the bottom of the block and the top of the ground, that friction is called as kinetic friction. Why we are saying kinetic? Because the block was slipping. You can see block is slipping on the ground. Okay, it's not about block is moving. Again, I would want to show you this example. Here also the remote is moving. Here also you can see that remote is moving. You can see this remote. So remote is moving. Okay, but the friction was static because it was not slipping. Now the slipping happens. Okay, so when there is slipping happening, then the friction is called as kinetic in nature. Its value is always constant, which is mu k into n. Its value is always constant, which is mu k into n. So what was mu s, guys? Mu s was the coefficient of static friction. What is mu k? Mu k is the coefficient of kinetic friction. Okay, generally speaking, mu k is always less than equals to mu s. Okay, maximum value of mu k can be mu s, but generally speaking mu k will be less than mu s. Okay, why is this so? We will talk about very shortly. In the questions, when only coefficient of friction is mentioned, suppose we will do a question and you will see that it is not given whether it's a static friction coefficient or a kinetic friction coefficient. They simply say that coefficient of friction. Then we will assume that coefficient of kinetic and static are equal, and it is equals to that value. For example, in a question, if it is given that coefficient of friction is 0.5, they have not said that whether it's kinetic friction ka coefficient or static friction ka coefficient. Then what we will do? We will assume that coefficient of kinetic friction is equal to coefficient of static friction. That is what we are going to assume. As simple as that. Not an issue, right? So kinetic friction is very, very important. If slipping is happening, the friction is called kinetic in nature. If slipping is happening, friction is called kinetic in nature. In that case, value of friction is always constant. Its value is mu k into n, and mu k is called as coefficient of kinetic friction. This is what we can say. Okay. So basically, guys, this is a very, very nice graph. You can see very, very nice graph. Very, very a super picture. You can see what is happening here. Here the applied force. So so you see what is happening over here, and correspondingly graph also you see. Okay, so applied force, you can see applied force is increasing, so friction is increasing. Applied force increases, friction increases. Applied force increases, friction increases. So this is static friction. Now applied force increases beyond a certain value. Okay, what is that certain value? Limiting friction. So block starts moving. Okay, so till the time applied force is less than, so you can see it's still equals to, friction is equals to applied force. That means this is static, 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 kinetic. Okay, so again I will tell you. Okay, again you see, so applied equals to friction, static, 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 kinetic. Okay, so I guess you can understand that the moment slipping starts happening, friction becomes kinetic in nature. Okay, so you can see the graph also. Here there is friction and here there is applied force. So you can call it F if you want. Okay, so basically what is happening, you can see friction and friction and applied force are equal. Friction and applied force are equal. Friction and applied force are equal. Why are they equal? Because the block was not moving. Friction and applied force are equal, but which friction? Static friction. So till the time motion is not happening, we can say that net force is zero. We can say that net force is zero because acceleration is zero, right? This F and this friction is balancing, so F is equals to Fr. Okay, so acceleration is zero. Okay, so this friction is static. This friction is static. So you can see that friction and F is equal. So this angle will be 45 degree, because why this angle will be 45 degree? Why? Because this will be a line, y equals to mx, and m will be 1, slope will be 1. In mathematics you might have been taught. If you have not studied a straight line in mathematics, then you will not understand this 45 degree. So you can skip it as of now if you have not studied mathematics straight line chapter. Okay, so you can see friction and F will be equal, and after this point, okay, after this value, what happens? After this value, slipping starts happening. Okay, so can we say that at this point friction has become equal to what value, guys? This is what value? This is mu s into n, right? This is the maximum friction that can be applicable. Okay, and as you can see after this, so friction increases, becomes maximum at this point, and this value is mu s into n. After this, you can see friction decreases slightly because friction has become kinetic, and you know what I told you, that mu k is generally less than mu s. Okay, its maximum value can be mu s k equal, but generally mu k is less than mu s. So you can see after this friction is becoming constant, and this value, my dear students, is mu k into n. Okay, so I hope you have understood what is this graph trying to tell you. Okay, again I will repeat, when the force is being applied, so till the time motion is not happening, till the time slipping is not happening, till that time acceleration is zero. Hence F is equals to friction, and which friction? Static. Why? Because slipping is not happening. Okay, so F is equals to FRS. Hence we can say that graph will be y equals to x type of graph. So which is this part? But the moment applied force increases beyond maximum value of static friction, which is limiting friction, which is mu s n, after this friction becomes kinetic. And we can say that slipping starts happening, and kinetic friction, my dear friends, is constant. So you can see, even if the force is increased, kinetic friction is not increasing. Its value has become mu k into n. So guys, I hope you have understood everything nicely on this graph. It was a very nice graph. Okay, now let's see what causes friction. Why does friction come into picture? See, reality mein, like can you see this remote? Can you see this? So you might can you see this? I think now you can see, right? So you might feel that's a very smooth surface. But if you see with microscope, it will not be very smooth. It will be very rough. It will be like with lot of craters and lot of edges, sharp edges, as you can see over here. So basically, to our naked eye, something might look very, very smooth, but if you look with microscope, then it will be like this, like shark teeth. Have you seen shark teeth? Very, very powerful. So like that. So when two surfaces try to slide on each other, okay, or try to move on each other, okay, try to slip on each other, then you can see interlocking kind of thing can happen, because to our naked eye it feels smooth, but in reality it is not smooth. So interlocking can happen, okay, interlocking can happen. That, what is interlocking? Basically you can see that this point going inside this point going inside, so basically locking, or locking kind of thing can happen, okay. This kind of creates friction. See, if you try to push this object B, okay, so because of this interlocking, because they are trying to lock in each other, so that is the reason, you know, friction arises, because it will be very, very difficult to move this block B, okay. Even the smoothest kind of surface, if you can think of, will have some amount of interlocking also. And also guys, one more reason, if you think of, there will be bonding between the bottom surface of object B and the top surface of object A. See, there will be lot of molecules on the bottom surface of object B, right? And there will be lot of molecules on the top surface of object A, right? So these molecules, that means bottom surface of object B and the top surface of object A, they apply electromagnetic force on each other, okay. So you can think that these electromagnetic force are bonds. Think in terms of chemistry, you know chemistry, so think in terms of bonds. So these are bonds which are formed. So now if you have to move the object B, so you have to break the bonds, okay. And think, if object B is at rest or is not slipping on object A, object B is not slipping on object A, then the bonds will be stronger. That is why coefficient of static friction is very high. But if the object B was slipping on object A, then the bond formation happens, but it will be very weak, okay. So in that case, we can say that coefficient of kinetic friction will be less. See, try to think, if you and your friends, okay, suppose you both spend 3 years together, then your friendship will be very, very strong. Bond between you and your friend will be very, very strong. But if suppose you met another guy just for 1 day or 2 days, so in that case we can say time is very, very less. So in that case we can say that bond between you will be very, very small, like not very strong. So same thing, object B at rest on object A, so that means molecules are at rest. They both the like surfaces, the molecules of bottom surface of B and the molecules of top surface of A, they are not slipping on each other. In that case we can say bonding is very strong. So in that case coefficient of static friction, which is the static friction, okay, that is very, very strong, okay. So that is why static friction is stronger, okay. But if the object B starts slipping, so in that case bond formation does not happen properly. So in that case we can say that friction is not very high in comparison to static friction. So we can say that in that case mu K becomes less than mu S. So this is the reason. I hope you have understood, okay. So this was the cause of friction, okay. So guys, I hope you have understood. Now let's do lots of problems. Theory part is over. So as long as theory is concerned, it's over. See, friction, if you want to understand properly na, theory say you will not understand. Do lots of problems. So now we are going to do lots and lots of PYQs, so that we can understand fully whatever we have studied today, okay. So problem time guys, and actually it's good, because more problems you do, better your understanding will be. So I've taken lots and lots of PYQs. Before this, let's start with a very easy question. Discuss the variation of frictional force. Discuss the variation of frictional force when a horizontal force applied increases from 0 to 10 Newton. Okay. So suppose we have an applied force F like this. We have an applied horizontal force F like this, and that value is going to increase from 0 to 10 Newton. Okay. Now, first of all, calculate normal reaction. So what is normal reaction guys? Very, very simple. We can say that normal reaction will be is equals to mg in this case, which is 3g, which is equals to 30 Newton. So all of you will agree that normal reaction value is 30 Newton, as simple as that. So let us first calculate what is the value of limiting friction. What is limiting friction? Try to recall. Limiting friction is that value up till which friction can increase. Which friction? Static friction. So limiting friction is that value up till which the static friction can increase. Okay, so what is limiting friction? So limiting friction is 0.2 into normal reaction. Okay, mu s into normal reaction. So mu s is 0.2. So this will become 20 Newton. No, sorry, 6 Newton. Not 20. 6 Newton. 0.2 into 30 is 6, right? 6 Newton. Okay, that means friction, static friction can increase its value up till 6 Newton. Okay, and what is the value of kinetic friction? Let's also calculate that. So kinetic friction will be is equals to 0.18 into normal reaction. So that means 0.18 into 30. So 1.8 yani 5.4 newtons. 5.4 newtons. Okay, so 5.4 Newton is the kinetic friction. Okay, now as you start increasing the value of F from 0, what will happen? You can increase the value of F from 0 to 6. Block will not move because friction will act in the backward direction. Okay, block is trying to slip in the forward direction on the ground. Block is trying to slip in the forward direction on the ground. So what will happen? Friction will try to say no, don't move. That means friction will oppose the motion of the block, right? So we can say that F will be is equals to till what value static friction can increase? Till what value? It can increase till 6 Newton. That means if you apply, so let me draw a table. Okay, let me draw a table. Force versus friction. And let me also show you acceleration. So if what is the value of the force? Let us say force is 0. So what will be friction? Friction will also be 0. If you don't apply, then friction is not required. If you don't apply any force, then there is no tendency of slipping. Block is not trying to slip. If block is not trying to slip, friction will not come into picture. As simple as that. If you don't apply force, friction will not come into picture. Acceleration will be 0. Suppose force becomes 1. So friction also will become 1 because friction can increase its value up till 6. So acceleration will be 0 because block will not move because static friction. Suppose you apply 6 Newton. What will happen? Friction will increase to 6. Friction can increase its value up till 6. So this is still static friction. Acceleration is 0. Okay. Now suppose you increase the value till 10, up till 10, or let's say you make the value 10. Now 10 is greater than 6. So this is applied by whom? This is applied by Bahubali. So Bahubali is applying 10 Newton force. So we can say that friction is 6. That means, no, friction is not 6. This is the catch. So 10 is greater than 6. You have to say that 10 is greater than 6. That means now friction cannot increase beyond 6. Think in this line. Think like this. Friction cannot increase beyond 6. That means block will start moving. Block starts moving. That means friction becomes kinetic because block starts slipping. Block starts slipping, friction becomes kinetic. And what is the value of kinetic friction, guys? Kinetic friction is 5.4. So what we can say? We can say that force was 10 Newton. Kinetic friction has become kinetic. So what is the total force? So F minus friction upon, so this is the total force. So we can say that what will be the acceleration, guys? F minus kinetic friction, okay, upon mass. This will be the acceleration. Yes, force minus friction upon mass, total force. So what will be this value? 10 minus 5.4. So this is 4.6. Mass I think is not given. So mass is 3 kg. Okay. So 10 minus 5.4 is 4.6 by 3. 4.6 by 3. So this will be the friction will become 5.4. Okay. And this will be 4.6 by 3. I hope, guys, you have understood. I hope you have understood. Okay. So very, very important. So this is a nice question which clears the very basic concept of how friction will vary. Okay. Find the acceleration of the blocks in the following cases. Let us see. So here mu is 0.6 and here mu is 0.2. So what is happening? Again, since remember what I had told you, if they have not said that this is coefficient of kinetic or static, we will assume that static is also 0.6 and kinetic is also 0.6. That is what we are going to assume. Okay. So let's do this question. What is the value of normal reaction here? So value of normal reaction will be, we can say that normal reaction will be 40 here. Right, mg. So what is the static friction? What is the limiting friction? That is up till what value friction can increase itself. So that will be 0.6 into 40. 0.6 into 40. So that means this will become how much? 24. Oh yo, 24 Newton. Oh no, 24 Newton. That means friction can increase its value up till 24 Newton. Okay, and friction will act in the backward direction because you try to pull the block in the forward direction. So block will try to slip in the forward direction. So limiting friction will, friction will act in the opposite direction, which is backward. Okay, so we can say that 24. So will the block move? No, because you have still applied 24 Newton. You have still applied 24 Newton. So block will not move. Okay, so acceleration will be 0. acceleration will be 0. Okay, so I hope you have understood. Acceleration will be 0. Okay, and here what is happening? So here again the friction, let's find the normal reaction. Normal reaction will be 30 here, so we can say that normal reaction will be 30, right? So what is the value of the limiting friction here? Limiting friction will be 0.2 into 6, that 0.2 into 30, that means 6 Newton. Okay, so how much force we have applied? So we have applied 18 Newton, that means it is greater than 6, so that means block will move, block will slip. So what will be the acceleration? So what is the value of kinetic friction, guys? Because block is going to slip, so kinetic friction will come into picture. So we are assuming mu s is equals to mu k, so we are assuming this to be equals to mu k, so that means kinetic friction will also be 6. So what will be the acceleration? Friction will act in the backward direction, so acceleration will be is equals to 18 minus friction kinetic, which is 6, divided by mass. That means 18 minus 6 is how much? 12. 12 by 3 is 4 meter per second square. This will be the value of the acceleration. Okay, I hope you have understood. Okay, guys, I would want to discuss one more important concept. Hold on. Yeah, I would want to discuss one more important concept for this part. Okay, let's see. So I hope you have understood this. Let's see. Okay, so I am taking the data itself. Very important concept. Please try to think. Please try to see what is happening. So 4 kg. Okay, this is F. Okay, mu is equals to how much it was given? 0.6 was given. You can see 0.6 was given. Okay, right. Now if I ask you what is the minimum force F so that this block just starts moving? What is the minimum force F so that this block just starts moving? Okay, now, so what will you think? You will think that this block starts moving if the applied force is greater than static friction, limiting friction, sorry. If this condition holds, then block will start moving. Say yes, say yes. If F is greater than Fr limiting, the moment F becomes greater than Fr limiting, the moment F becomes greater than Fr limiting, block will start moving. Say yes. So we can say that. And what is Fr limiting? That is mu s. So this is mu s. So mu s into normal reaction. Okay, that means what is mu s? Mu s is 0.6, and this is what is normal reaction? Normal reaction is 40 here. That means if F is greater than 24 Newton, block will start moving. Okay, if F is greater than 24 Newton, block starts moving. Okay, but I am asking what is the minimum value of F? What is the minimum value of F so that block moves? Think, what is the minimum value of F? Okay, now if you think F is 25, so I am asking what is the minimum F? What is F min? Okay, so that block moves, so that block moves. This is what we want to find. Okay, what is F min? So that block moves. Okay, so we know that it is greater than 24, but what is the minimum value? So what is the value? So we have to select a value which is just greater than 24. So if you think it is 25, then you are wrong, because there are infinite numbers between 24 and 25. 24.1, 24.2, 24.3, all these are less than 25. If you think it is 24.1, then also you are wrong. There are infinite numbers between 24 and 24.1, like 24.01, 24.02. If you think it is 24.01, then also you are wrong, because there are infinite numbers between 24 and 24.01. So I hope you understood what I am trying to tell you. You are getting the idea. It is a number which is slightly greater than 24, slightly, but we cannot write that number. You can say 24 plus or 24.000000001, like that. So but again, we cannot write that number. If you, like, we have written 40, we have written 0.6, we have written 24, but you cannot write that number. Okay, you will have to write 24.0000. How many zeros will you write? So we say that let it be 24. So what we say that minimum force which can move this block is 24. We say that conventionally. Okay, although we know that at 24 block will not move, it will be about to move, it will be on the verge of sliding, it will be on the verge of slipping. At exact 24 block will not move, we know that, but we also know that the value slightly, even a bit more than 24 can move this block. Hence, if we are asked that what is the minimum value of F such that the block moves, then we will say that let it be 24 only. Okay, let it be 24 only. So please remember this concept. This might confuse you many times, that if I ask you what is the minimum value of force F which can move this block, then all you have to do is that for minimum just do F is equals to FR limiting. So this will give you minimum value of force, so which is mu s into n. Okay, I hope guys you have understood. So at this condition block will not move, we all know that. Okay, let me switch off the ACR. Please, yes. Standing, I started. Yeah, so I was saying at this value of F is equals to mu s into n, block will not move, we all know that. But we also know that just more than this, slightly, little bit more than this, block will move. So we say that, okay, let's say that block will move at 24 only. We know that that value is like very minuscule, very tiny more than 24. So we can say that okay, 24 pe move the block. Okay, so try to understand. What is the minimum value which can move the block? Limiting friction. What is the maximum value up till which block does not move? If I say how much force maximum you can apply so that block does not move, again the same value, 24 or mu s into n. If you apply mu s into n, block will not move. This is correct. Okay, that is the maximum value. So maximum force how much you can apply? Mu s n. If you apply more than mu s n, block will move, definitely. So maximum force which you can apply so that block does not move is mu s n. Minimum force which can be applied, which should be applied so that block moves, is slightly more than mu s n, but we loosely say that let it be mu s n. I hope I was able to clear your understanding on what I was trying to say. It's important. Okay, now this is a very nice question. Find the minimum force required to start the motion, and the coefficient of friction is mu. Coefficient of friction is mu. You can call it to be static or kinetic. Okay, so this is an advanced question. So I hope like many of you would simply say that just now we said this so many things, mu s n. Minimum force required to move the block is mu s n. Just now we discussed so much about this. So answer should be mu s into n, right? Wrong. See, if the question was find the horizontal force, they have not given the angle on which the force is applied. If the question was like this, that apply this kind of force, then the answer was mu s n. But they have not given the angle. That means force can be applied at any angle. It is our choice. It is our choice. Okay, so what will happen, guys? Let us say that force is being applied at an angle theta. So now theta is also a variable for us. Theta is also a variable for us. We can choose any theta as we want. The objective is to minimize the value of F. This is the objective. So we have to find the minimum force F so that block moves, and theta is our choice. We can choose any theta. Okay, so guys, again try to think what I said. Minimum force so that block moves. So what should be the condition? So let's break this force. Let's break this component. Let's do the component of the force. So what is the horizontal component, guys? So horizontal component will be F cos theta, right? And what will be the vertical component? So vertical component will be F sin theta, right? And what are other forces acting in the vertical direction? So normal reaction from this and mg from this side. So normal and mg will also act beyond F cos theta and F sin theta. Okay, so what will be, so of course block will not move in the vertical direction, because like block will move, if we want to move block horizontally basically, so we can say that F sin theta f sine theta, which is in the vertical direction, okay, plus normal reaction, that will be is equals to mg. Okay, that will be is equals to mg. So from here you can say that normal reaction becomes mg minus f sine theta, right? Okay, and remember what I said. Okay, now this can be thought of as the horizontal force. F cos theta is the horizontal force. So if this becomes equal to limiting friction, if this becomes equals to limiting friction, then we can say that block will be on the verge of sliding. If this becomes equals to limiting friction, then block is on the verge of sliding. Yes, so we can say that f cos theta, if f cos theta is equals to mu s into n, okay, which is friction limiting, then we can say that block is on the verge of sliding. So this we can say that mu s, okay, so this is mu s only, okay, mu s into normal. What is normal? Mg minus f sine theta. Okay, mg minus f sine theta. So this is f cos theta. I hope you have understood. So actually if this condition will hold, so block will not move. You understand that? If this condition will hold, block will not move, but will be on the verge of motion, will be just about to move. Okay, I hope you are understanding. So from here we can see that f comes out to be mu s mg. Okay, you can take this term on the right side. So you can see that f, you can take mu s f sine theta on the left side, so and take f common, so this will become cos theta plus mu s sine theta, that should be is equals to mu s mg. Okay, so what is the value of f? So f becomes is equals to mu s mg divided by cos theta plus mu s sine theta. Okay, now still this is not the answer, because here theta is the variable. Theta was not given in the question, so we have to eliminate theta. Okay, now look at this. See, mu s is given in the question. Mu s is a constant value, mu s is a fixed value, m is the mass of the block, it is a fixed value, g is gravity, which is fixed value. Theta is not a fixed value, theta is our choice. So we have to select such a theta so that f becomes minimum. This is our objective. Okay, now look at the denominator. So let us see that denominator. So I'm calling denominator as d. Okay, so what is denominator? So mu s sine theta plus cos theta, this is the denominator. Okay, so if denominator becomes maximum, you can see if denominator becomes maximum, then f will become minimum. Very obvious. Okay, f is some value upon denominator, and if denominator becomes maximum, f will become minimum. Very obvious. Okay, now you might have been taught about this in mathematics in trigonometry chapter, that any expression, I will show you, if suppose any expression E is of the format a sine theta plus b cos theta, if E is of this format, then E can be written as under root of a square plus b square into cos of theta minus alpha, where tan alpha is equals to b by a, a by b. So I don't know if you have been told this or not, but this is a very important thing which is taught in mathematics. If you know this, then also we will solve. If you don't know this, then also I will solve. Okay, suppose you know this, suppose you know this, then you can see that a is acting as mu s and b is acting as 1. Here 1 is written. If you know this, then this denominator can be written as under root of mu s square plus 1 into cos of theta minus alpha, where tan alpha will be equals to mu s by 1. Okay, so if you know this, then you will do this. Okay, so denominator ka maximum value, what will be the maximum value of denominator? Of course it will be this will be the maximum value of denominator. Okay, and this will happen if cos of this becomes 1. Okay, if cos theta, what can be the maximum value of cos theta? If this is 1. Okay, so hence we can say that d max is nothing but under root of mu s square plus 1. And when will this happen? This will happen if cos theta becomes 1. Cos of this thing becomes 1 and this thing will become 1. When is cos when does cos becomes 1? If the angle is 0. That means theta minus alpha should be 0. Right? So theta should be is equals to alpha. Okay, and what is alpha? That means theta is equals to tan inverse mu. You can see alpha is tan inverse mu. Tan inverse mu s. So this is the value of theta. Hence what we have proved, that you have to apply the force at an angle of tan inverse mu s. You have to apply the force at the angle of tan inverse mu s, and what will be the minimum value of the force? So now we know the maximum value of denominator. So what will be the minimum value of force, guys? F min. Put that maximum value of denominator. So this maximum value of denominator was under root of mu square plus 1. So this will become mu s mg, okay, divide by under root of 1 plus mu s square. Please remember this value, guys. Please remember this. Please remember this. Please remember this. Very, very important. Okay, and when will this happen? When theta is equals to tan inverse mu. When theta is equals to tan inverse mu. I'll explain this result. First, let me prove this result by one more method. For those of the students who do not know this, okay, so we can use what? We can use mathematics differentiation maxima minima. Okay, if you want to maximize denominator, okay, so let's call this as y. Let's call this as y. Y is a function of theta. So y is equals to mu s sine theta, okay, plus cos theta, right? So what is dy by d theta? So dy by d theta should be is equals to sine. What is the differential coefficient of sine? So it is cos theta. Okay, and what is the differential coefficient of cos? It is minus sine. So it should be 0 because y is maximum. So you know, if y becomes maximum, then dy by dx should be 0. So here dy by d theta should be 0. So from here you can see that tan theta becomes mu s. Tan theta becomes mu s. Okay, so that means theta becomes tan inverse mu s. Theta becomes tan inverse mu s. Okay, and what is the value of y? What is the value of y? So if tan theta is mu s, you can draw a triangle. Okay, you can draw a triangle. Suppose this is theta. So tan theta is mu s. You can see tan theta is mu s in this triangle. Okay, so if this is mu s, this is 1. So this will become 1 plus mu s square. Arre gotcha. Got it. So y is equals to mu s into sine theta. So what is the value of sine theta? Sine theta you can see from here is mu s upon under root of 1 plus mu s square, right? Plus 1 into cos theta. So what is cos theta? Cos theta is 1 upon under root of 1 plus mu s square. So what does this become? 1 plus mu s square upon under root of 1 plus mu s square. So this will become under root of 1 plus mu s square. So this will be the maximum value of y, dear students. This will be the maximum value of y, which we have just proved, and this will happen if theta equals to tan inverse mu s. So this we have proved using differentiation. Okay, so again you can see that here we had called that expression as d. Now we are calling that expression as y. So y maximum value is coming out to be this, and this happens if theta equals to tan inverse mu. Same result. Okay, so all in all, you need to understand that minimum value of force occurs when the force is applied at an angle theta, where theta is tan inverse mu, okay, tan inverse mu, and the minimum value is mu s mg upon under root of 1 plus mu square. Let me explain this result once more. So suppose this is a block. Okay, suppose this is a block. Okay, suppose mu s is equals to 1 by root 3. Suppose this is the value of the coefficient of static friction. Okay, and let's say mass of block is m. Okay, let's say 5 kg. Okay, mass of block is m. So if you want to move this block by applying minimum force, and it is not said that force is horizontal, you can choose any angle. So what is the idea? You should apply the force at an angle like this, such that this is theta, such that tan theta should be mu s So that means 1 by root 3. That means theta should be is equals to 30 degree. Hence, you will have to apply the force at an angle of 30 degree. And what will be that force? So what will be the minimum value of force? So you can see that value will be mu s mg divided by under root of 1 plus mu s square. This is the minimum value. So you can compute this 1 by root, this is 1 by root 3 into mg will be 50 upon, so this will become 1 plus 1 by 3. So 4 by 3 I guess. So 1 by root 3 into 50 divide by, this will become 4 by root 3, so this will become 2 by root 3, right? So root 3 gone, so 50 by 2, I think 25 Newton. 25 Newton will be the minimum value of force that needs to be applied so that block moves. Okay, so again try to recollect. At 25 Newton, block will be on the verge of sliding. That means it will be just about to move. If you apply the force slightly more than 25, block will move. Okay, I hope you have gotcha. So this was a very, very useful result, guys. This was a very, very useful result. Please do remember this result. Minimum value is mu s mg divided by root of 1 plus mu s square, and the force should be applied at an angle of tan inverse mu with respect to horizontal. This question is also present in HC Verma. Okay. So this question, JEE Main, 31st January 2023. Let us see. A body of mass 10 kg is moving with an initial speed of 20 meter per second. The body stops 5 seconds due to friction between the body and the floor. So what is happening? Suppose this is a block. Okay. So block is of mass 10 kg. Its initial speed was 20 meter per second. Let's say is moving towards right. Okay. It stops after 5 seconds. So that means friction would be acting in the backward direction. Friction would be acting in the backward direction. Okay. And this will be kinetic friction. Okay. This will be the kinetic friction. Okay. So that will be is equals to mu k into normal reaction. Okay. And what is normal reaction, guys? Normal reaction will be mg. So we can say that mu k into mg, right? So velocity is forward direction, hence we can say that, see, only force acting on the block is in the backward direction, which is friction. Okay, I mean the horizontal force. In the horizontal direction, can you see how many forces? One force, only friction. So friction is acting in the backward direction. Okay, so that means acceleration will also happen in the backward direction. Okay, acceleration will also happen in the backward direction. Block is moving in the forward direction, acceleration will happen in the backward direction. So what will be the acceleration, guys? Acceleration will be friction upon mass. That means mu k mg divided by m. So this will be mu kg. This will be mu kg. Okay. So now what we can find this acceleration by using kinematics also. It has been given that block stops 5 seconds after motion. So we can say we can use v is equals to u plus at. Okay. Because we know that acceleration is constant, mu k is constant, g is constant, velocity becomes 0. Okay, initial velocity was 20, acceleration is towards left, so I am writing it as minus a. Okay, into time. Time is how much? 5 seconds. So from here acceleration comes out to be 4 meter per second square. Right? So that means this mu kg will be equals to 4. So we can say that mu k into g, that should be equals to 4. So that means g is 10, so that means mu k will be 0.4. Okay, and again, as I said, it is given coefficient of friction, so we will assume it to be kinetic equal to static because it is not specified. So we will assume coefficient of friction is 0.4. Option D will be the correct answer for this question. I hope you have understood. So this was a JEE Main question this year itself, very, very easy. You can see how easy question. How much easy question. Okay, so 0.4 is the answer. JEE Main PYQ again. So here gravity we have to take 9.8. Be careful slightly here. Okay, we have a habit of taking 10, but here gravity is 9.8. A block of mass 0.1 kg is held against a wall by applying a horizontal force of 5 Newton. So what is happening? So basically this is a wall. Okay, this is a wall. Okay, so we have kept a block. We have kept a block like this. right? By applying a horizontal force, of 5 Newton. So this type of force we have applied, okay? And the mass of the block is 0.1. Kg, okay? So coefficient of friction is given as 0.5. So mu is 0.5. Again, we will assume mu s is equals to mu k is equals to 0.5. Then magnitude of friction force acting on the block. Now this is slightly tricky. Try to think what is happening. First, tell me what will be normal reaction applied by the wall. So can you say that normal applied by the wall will be in this direction? Because if you are pushing the block like this, so normal applied by the wall will be in this direction, and we can say that block is not going to move along this axis. Okay, block of course cannot break the wall and you can go inside, not going to happen. Block cannot come towards left. You are pushing like this, so how can block come towards left? Okay, so we can say that block, so this axis equilibrium, x-axis, block is in equilibrium, so we can say that normal reaction will be equals to how much? 5. So we can say normal reaction is nothing but 5. Okay, so how much is the limiting friction? That means how much friction is available. That means maximum value of static friction. How much? So how much is the limiting friction, guys? So limiting friction is 0.5 into 5. So that means this is 2.5. But is this the value of the friction? We are not asked the limiting friction, we are asked the static friction. Okay, so try to see the question, and block is held against the wall. That means you are pushing the block and block is at rest. Okay, now there is one more force which is acting in the downward direction, which is mg. So what is the value of mg? So 0.1 into 9.8. So this becomes 0.9. Oh no, this becomes 0.98 newtons. This is the value of mg. Okay, so if block is not slipping down, so who is stopping? So friction. So see, there are two surfaces. One is this wall, which is green colored, and one is this block. So the right surface of the block. So friction will be acting in the upward direction. Why upward direction, guys? Think. Because if friction was not there, then block would have simply fallen down. Block would not have, tried to stay in that position. Block would have simply tried to slip down. So friction will try to stop this. Friction will always try to stop the friction always opposes the slipping, okay, or the tendency of slipping. So here the block would have slipped down, so friction will act up. Okay, so now this friction is going to stop and which force is causing the block to go down? So it is mg. This is 0.98 newton, which is causing the block to go down. Okay, so how much force do you think is required to stop this block from falling down? How much? Okay, so of course this point, if we apply the force, that means if the friction becomes 0.98, if the friction is 0.98, then this block will not go down, right? So try to think about static friction. Although the static friction available is 2.5, that means if the requirement of the static friction was a 2.5, then it would have been like that much friction was present. But how much is the actual requirement? Actual requirement is just 0.98. We don't need 2.5. So we can say that friction value will be actually is equals to 0.98 Newton, not 2.5 Newton. So we can say that option C will be the correct answer for this question. I hope guys you have understood this. Okay, this is not 2.5, the answer will be 0.98 newtons. Okay, block will not fall down because we just need 0.98 newtons friction. Okay, I hope guys you have understood. Let's move forward. Okay, a block rests on a rough inclined plane making an angle of 30 degrees with the horizontal. So let's draw the situation. So basically this is an inclined plane and this angle is how much? 30 degrees. Okay, the coefficient of friction, static friction between the block and the plane is 0.8. So this is the value of mu s. Okay, if the frictional force on the block is 10 Newton, then the mass of the block. Okay, so basically the question says that block rests, that means block is not moving. So we can say that if m is the block mass of the block, so basically you can see, let me try to show you the forces which are acting over here. So one will be this normal reaction from the inclined plane. Okay, so mg ko we can resolve. So mg ka this component will be mg cos theta, right? Mg cos 30, and this component of mg will be mg sin 30. We all know this. Okay. Hence, see, if the friction was not there, then this block would have simply slipped down. Block would have simply slipped down. So we can say that friction on this will act in the backward direction. That means up the plane. Friction will act up the plane. Why? Because the block would have slipped in the downward direction, down the plane. Okay, law of nature. So that means now this block is not slipping. So we can say that, so basically this block is at rest. So we can say that friction will be is equals to mg sin 30. Friction will be is equals to mg sin 30, and this friction will be is equals to, so we can say that this value of friction was 10. Okay, again, do not write friction is equals to mu mg cos. Do not write friction. If you are doing this, friction is equals to mu sn. Okay, and if you equate this, then this will be wrong, guys. Why? Because here, how do you know that friction has achieved its maximum value? Do you know that friction is maximum? Do you know that maximum value of friction is acting? No. You just know that block is not sliding. That means it is a static friction. You only know that block is not sliding. That means it is a static friction. But static friction can have any value between 0 to limiting. That means from 0 to up till mu s n, it can have any value. So we do not know what is the value. So you should not equate it to mu s n. What we know, that block was not sliding. Hence, the net acceleration was 0. That means up the plane force friction would have balanced mg sin theta. That is what we know. I hope you have understood. Okay. So friction is 10. That should be equals to m into g is 10 into sin 30 is half. So from here you can see that m comes out to be 2 kg. I hope, guys, you have understood this question, which was JEE main PYQ. Pretty simple although. Okay, pretty simple. Let us see this question again. JEE main this year PYQ. A block of mass m slides down the plane inclined at an angle 30 degree with acceleration g by 4. So that means what is happening? This is again, you can see theta will be is equals to 30 degree. Okay, and this block of mass m slides down with an acceleration g by 4. So what is the force acting in this direction? This force will be mg sin 30, right? And here the block is sliding down. That means friction will be kinetic. Okay, and friction will act in the back up the plane direction, because we can say that sliding is happening in the down the plane direction. So kinetic friction, you know, it's the value of the kinetic friction is constant. Its value is always mu k into n. Okay, and what is the value of n here, guys? What is the value of n here? So value of n here will be mg cos theta, mg cos 30. Can we say that? Because block is sliding in this direction, there is no motion happening in this axis. There is no motion happening along this axis. So that means we can write friction kinetic is equals to mu k into normal. And what is normal? It is mg cos 30. Yes. Okay. So what is the total force acting on the block, guys? So force acting on the block will be mg sin 30 in this direction minus friction kinetic. Okay. So what is the acceleration? So mass into acceleration will be is equals to mg sin 30 minus friction kinetic, which is mu k mg cos 30. I hope you have gotcha. I hope you have gotcha. Okay. So this is net force mg sin 30 minus mu k mg cos 30, and this will be is equals to mass into acceleration. Okay. So from here m will kill each other. So a is given as g by 4. That will be is equals to g sin 30 will be g by 2 minus mu k into g into root 3 by 2. Cos 30 is root 3 by 2. G will also kill each other. Okay. So from here you can see that mu k into root 3 by 2, that will be is equals to 1 by 4, right? So what is the value of mu k? Mu k comes out to be 1 by 2 root 3, right? Option B. I hope you have got it. Simple enough. No problem whatsoever. Okay. Let us see this question. Okay, again JEE main question. This is slightly good question. Minimum force required to start pushing body up a rough inclined plane F1 is F1. Okay, while the minimum force needed to prevent from sliding is F2. So basically what is happening, see, suppose this is an inclined plane. This is angle theta. We have also been given tan theta is equals to 2 mu. Mu is the coefficient of friction. Okay, now suppose this is a block of mass m. Now see, let me draw the forces first. So one will be this normal reaction. Okay, normal reaction will always be acting in this direction. Mg cos theta will always act in this direction, right? And mg sin theta will always act in this direction. Okay, and normal will always be equals to mg cos theta. These things are fixed. These things will not change. Okay, now suppose you want to push the body up the plane. That means you will have to apply a force F like this. So you have, if you apply the force F like this, okay, so minimum force F like this, so body might start going up the plane. So body is on the verge of moving in the upward direction. So think in what direction friction is acting. So if body is about to move up, that means friction is acting in the downward direction, because slipping is going to happen in the upward direction. So friction will be acting in the downward direction in this case. And when the body is just about to move, so friction would have become limiting. Can we say that? See, body is on the verge of sliding. Why? Because we have to find minimum force. So just that much force, so that block is just about to move in the upward direction. Okay. So can we say that this F will be equals to mg sin theta plus friction. Friction is also acting down, right? Because slipping is going to happen in the upward direction. So can we say that this F will be equals to mg sin theta plus limiting friction, which is mu into normal. Think guys, think. When you're trying to just push the block, so that means block is just about to move in the up the plane direction. That means you have balanced mg sin theta as well as friction. Mg sin theta is acting down, friction is acting down, because slipping is going to happen in the upward direction. So friction acting down. So if you have to just apply the minimum force, that means this force should be equal to mg sin theta plus friction, right? And this we are calling as F1, right? This is the first situation. This is the first situation. Okay. Another situation, F2 is just preventing from sliding down. What does this mean? Again, look. So suppose this is the inclined plane. Okay, suppose this is the inclined plane. Again, okay, and this is mass m and this is theta. So if you leave this block, okay, so what are the forces? Let me quickly show you. Again, this will be mg sin theta. Okay, normal. Mg cos theta. Okay, so if you leave this block will slide down. Okay, that means friction will act in the upward direction. And what kind of friction? Kinetic friction. Okay, now you have to okay, so basically see, so if we would have left this block, it would have simply gone down and the friction acting would have been kinetic. Okay, so suppose this value is 20. Suppose, just assume mg sin theta is 20. Assume 20 sin mg sin theta is 20. Assume friction kinetic is 16. Assume. Okay, so this is 20 and this is 16. That means net force down the plane is 4. I am saying call this value as 20. Okay, call this value as 16. Okay, that means net force down the plane is 4. So if you apply a force of 4 like this, 4, what will happen? Block will stop from moving. That means the minimum force that you should apply, so that block does not move is how much? Mg sine theta minus friction. And which friction? Kinetic friction. Actually it should be static friction. Actually it should be limiting friction, because once the block has stopped moving, suppose block is not moving, that means slipping is not happening, na? Think carefully. Suppose block is not moving. See, if you apply how much force, so that block is not moving. So if block is not slipping, in that case friction is static. So 16 is actually the maximum value of limiting friction, which is, sorry, maximum value of static friction, which is limiting friction. I hope you're understanding. See, suppose this is 20 and 16 is the static friction. 16 is the limiting friction. 16 is the limiting friction. So basically net force was 4. So if you apply the 4 force in the upward direction, so block will not move. So 16 is actually the maximum value of static friction. I hope you have gotten this. I hope you have understood this. Okay, hence F2 will be what? F2 will be mg sine theta. F2 will be mg sine theta minus mu s into n. I hope you have understood this, guys. So I'll write here F2 will be mg sine theta minus mu again, and here mu is, by the way, same, so we don't need to write mu s and mu k, it will be anyway same. So mu s mu into n. Okay, we have to find the ratio f1 by f2, and we have been given tan theta as 2 mu. So what is f1 by f2? Let us quickly see. So f1 by f2 will be, so divide this, so mg sine theta, okay, plus mu into normal is mg cos theta, okay, divide by mg sine theta minus mu into mg cos theta. Okay, right? Now think carefully what I am saying. I am taking cos theta common from numerator and denominator. So what am I saying? I am taking cos theta common from above. So if you take cos theta common from above, what will this become? This will become tan theta, because if you take cos common, so this sine by cos will become tan. So this will become tan theta. See carefully what I am saying. Okay, I am taking cos theta common from top, and here cos theta will be gone. So this will become mu mg. Okay, divide by, again cos theta common from the denominator. So this will become mg tan theta. Okay, minus mu mg, right? Okay, now you can see mg will be cancelled. Okay, mg, mg, mg and mg. What is the value of tan theta? It is 2 mu. So this will become 2 mu plus mu, 3 mu upon 2 mu minus mu. So answer will be 3:1. That means 3 only. I hope you have understood. This was a good question, guys. At least for beginners, this was a nice question. Okay. Okie dokie. Right. Angle of repose. So let us see angle of repose now. So guys, now let's see angle of repose. So you can see something I have held in my hand. Okay, I'm going to explain you angle of repose using this. Now you can see that this is the sort of thing that most of the times directors or the cameraman, I don't know which exact part of the filmmaking person holds, but you know, you might have seen, if you have ever seen the shooting, then they say light, camera, action. So this type of thing they hold. Okay, so I'm not going to do any such thing over here, but there's a specific reason I am holding this. Okay, so basically you can see this particular thing. Okay, what is this? Unity for humanity, whatever. So I guess you can see, yeah, I think now you can see this, right? So this is visible. Okay, let me keep something else. So this is the remote of AC. You can see now this will be visible to you, right? Yes, this I think is visible. Okay, so guys, now I will, of course, the very obvious thing is that if I keep on increasing the angle of inclination, then at a particular value of inclination, this remote is going to slide. So let's see. So you can see it starts sliding. In fact, it started sliding very easily. I'll do this again. So you can see at this angle. Oh no, my bad. Sorry. I hope it is working. Ah, yeah, it is working. Let me switch off the AC as well. Yes. So guys, it could have proved a very costly experiment, but trust me, what I just showed you is the method of finding the coefficient of friction also between the remote and the that object. Okay, but let me tell you, you saw that if we were increasing the angle of inclination, what did you observe? Up till a certain value of inclination, the remote did not slide. But after a certain value of inclination, or we can say that at a particular value of inclination, okay, the sliding was just about to happen, and the moment I increased beyond that, I increased the angle of inclination beyond that, remote almost started sliding. Okay, so we can say that what is angle of repose? Angle of repose is that angle of inclination, at which sliding is just about to happen. Okay, so what is angle of repose? Angle of repose is that angle of inclination at which sliding is just about to happen. So you can see over here, if we can keep on increasing the just a sec, yeah, if we keep on increasing this angle of inclination, okay, so let's say this is theta. So if we keep on increasing the theta, so at a particular value of theta, this block will start sliding in this direction. So that value of theta is called as angle of repose, and guys, that theta comes out to be tan inverse mu. Where mu is the coefficient of friction between the surface of the incline and the block. So what is mu? Mu is the coefficient of friction between the surface of the incline and the block, right? So this is also the method, as I was saying. I will prove this how we get this. Don't worry about that how we got this. I'm going to prove that very shortly. It's very easy way, by the way. Okay, this is also the method by which we can measure the coefficient of friction between the inclined plane and the block. For example, suppose mu is unknown. So right now, suppose we wanted to calculate the value of mu between the remote and that object. Okay, so again I will show you. Okay, so this time I am not going to allow it to fall. So suppose you can see the remote kept over here. So if I start increasing the angle of inclination, so you can see that remote has started sliding. Okay, I don't know if you are able to see that or not. I think, let me do this by this remote, so it will be visible, I guess, because this is black remote. I think now it is visible. Yes, now you can see it is sliding. Okay, so the angle at which sliding happens, that angle we can measure. Okay, that angle, that means we can measure theta. So once we find the value of theta, we can simply say that mu is equals to tan theta. Okay, we can simply say that mu is equals to tan theta, right? So that ways you can measure the value of coefficient of friction between the block and the surface of incline by measuring the angle of inclination, or by measuring the angle of repose experimentally. Okay, now the idea is that how do we get this? So very simple. Let me show you on the next slide. So here the angle of repose definition is given: the minimum angle made by the inclined plane with the horizontal at which sliding just is about to happen. Okay, so that angle, we know, I just told you that angle becomes tan inverse mu. Okay, again try to understand that at this angle sliding will not actually happen. It is the maximum angle at which sliding will not happen. If you increase the angle just more than this, then sliding will happen. So that means we can say that sliding will happen if you increase theta slightly more than tan inverse mu. If you increase theta slightly more than tan inverse mu, then the sliding will happen. So that is angle of repose. Okay, now how we will find this? So very simple. Very simple. Let us say right now, oh no, let us say right now the angle of inclination is equals to repose. That means right now this block is on the verge of sliding. Okay, so we can say that right now the block is on the verge of sliding. Okay, hence what can we say? That the downward force, which is mg sine theta, will be equals to the limiting friction. That means friction would have reached its limiting value. Friction would have reached its limiting value, right? So can we say that friction would have become limiting? Friction would have become limiting. Friction would have reached its limiting value. So we can say that mg sine theta. We can say that mg sine theta will be is equals to friction limiting, which is equals to mu into normal reaction. Right, mu into normal reaction. And what is the value of normal reaction, guys? Normal reaction is equals to mg cos theta. So we can say that mg sine theta, that will be is equals to mu into mg cos theta. Right, I hope you have understood from here. Right, so from here we can say that mg gets cancelled, so this becomes mu is equals to tan theta. This gives you the result mu is equals to tan theta, and hence we can say that when theta is equals to tan inverse mu, at that point sliding is just about to happen. So sliding is imminent. That means sliding is just about to happen. So we can say that this is the angle at which, if you increase the incline, then sliding will is just about to start. That means if angle of inclination is more than tan inverse mu, if angle of inclination is more than tan inverse mu, then we can say that sliding will definitely happen. Whereas if angle of inclination is less than tan inverse mu, then sliding will not happen. Less than or equal to tan inverse mu, then sliding will not happen. I hope you have understood this, guys. Okay, what we can say that if theta greater than tan inverse mu, sliding happens. Okay, sliding happens. Sliding happens. I hope, guys, you have understood. Okay, sliding happens. Right, if theta less than equals to tan inverse mu, sliding does not happen. Right, guys, I hope you have understood angle of repose. Sliding does not happen. Right, so this is the idea. Okay, let's see a question. If the coefficient of friction between an insect and a bowl is mu and the radius of the bowl is r, then the maximum height to which the insect can crawl in the bowl. So basically what is happening, suppose this is a hemispherical bowl. Okay, this is a hemispherical bowl which is fixed. Okay, this is the center of the bowl. Okay, point O is the center of the bowl. Okay, now the radius of the bowl is r, so we can say that this radius is r. Right, now an insect is crawling and climbing up, and an insect is crawling and climbing up. Okay, so basically let us say, so see what is happening. Insect starts from this point. Okay, it reaches here. Okay, so we have to see till what height it can reach. So see how can we do this question? Very simple. See, suppose an insect is able to reach till here. That means at this point inclination is like this. At this point you can see that inclination of the surface is like this. Okay, suppose insect is able to reach further. Okay, that means at this point inclination of the surface is like this. So see what is happening. As the insect is moving up and up, inclination of the bowl with respect to horizontal is increasing. Okay, so what is the last point up till which you can reach? So at the last point we can say that inclination of the surface would have become equal to angle of repose. Yes, so if the insect has reached over here, so we can say that at this point the inclination would have become equal to angle of repose. You can think as if this is the surface of, suppose the insect is able to reach till here. Suppose the insect is able to reach till here. So at this point we can say that this inclination, this theta, okay, this theta is equals to angle of repose. So I am erasing the remaining part so that for a better clarity. Okay, so I am just erasing this. I'll draw this again. Okay, so guys, yeah, so that means at this point, if you draw a tangent, so that means this is the angle. You can think as if this is the inclination. Okay, this is the angle of repose. This theta becomes the angle of repose, and this is the maximum height up till which it can go, because if it goes further, then inclination will increase further, and that inclination will be more than angle of repose. So we know that tan theta would have become mu. Tan theta would have become mu. Very simple. Okay, now we have to actually find the height. That means, so if you draw, this is radius, okay, and this is, so if you see, I draw a dotted line. So this angle we are calling as theta. So this angle will be 90 minus theta. Hence this angle will be again theta. Let me take another color. Okay, so this angle will be again theta, right? Hence this angle will be theta. So if you see, insect has reached till this point. So this is the height which insect has reached. Okay, so if you see, then this was the bottommost point. OP is equals to R, okay, and this value is equals to R cos theta, because this is R, this is also radius, and this angle is theta. So this value is R cos theta, right? Hence what is the height? Total OP minus R cos theta. Okay, this value is the height, H. So we can write H is equals to OP minus R cos theta. OP itself is R, so this becomes R into 1 minus cos theta. Okay, now what is the value of cos theta? So you can use the triangle. If tan theta is equals to mu, if tan theta is equals to mu, so this becomes under root of 1 plus mu square. So what is the value of cos theta? Cos theta will be 1 upon under root of 1 plus mu square. Gotcha? So this is the height up till which the insect would be able to crawl. Okay, after this the inclination will increase beyond the angle of repose and insect will slide down. Gotcha bacha. So I hope you have understood. Okay, let's move to the next. So this was the answer. Okay, now let's see what is angle of friction. Okay, so guys, what is angle of friction? Now suppose a block is kept on any surface, let us say on the ground. So you can see this red block. This is kept on any ground. We can say that. So ground is not shown over here. You can assume that the ground was here. Okay. So if you want to see the ground, I can show you the ground. Ground. So let us see, this is the ground. Okay. Now guys, ground can apply force in two directions. Okay. Or we can say ground can apply a force whose one component is called normal reaction and this component is called as friction. Basically, this force which ground applies is called as normal reaction, and this force which ground applies is called as friction. Okay, assume that block was being pulled, so that there is some friction acting. Okay, you can assume that block was being pulled by Bahubali or by any other person, so that there is some friction. So actually what is happening? In reality, ground is actually applying a single force which is called as reaction force. You can see here this R. So this force is what ground is applying. Okay, reality mein ground is applying a single force called as reaction force, and the component of the reaction force perpendicular direction, in the perpendicular direction, is called as normal reaction. So in reality, please try to understand what I am saying. In reality, ground is applying a single force which is reaction force. It is also called as contact force. Okay, so in reality, ground is applying one single force. So the perpendicular component of this force is called as normal reaction, and the parallel component of this force is called as friction. So basically guys, reaction force is the vector sum of friction and normal reaction. Do you understand this? So ground is actually applying one force. Okay, ground is not applying two force. Ground is applying one force which is called reaction force. So the perpendicular component of reaction force is normal reaction, and the parallel component of the reaction force is called as friction. Okay, now what is angle of friction guys? The angle between the reaction force and the normal reaction. That means what is reaction force? It is the resultant of friction and normal reaction. Okay, what is reaction force? It is the resultant of friction and normal reaction. So what is angle of friction guys? Angle of friction is the angle between the reaction force and the normal reaction. This angle, my dear friends, okay, this angle is called as angle of friction. Okay, so what is lambda? I have chosen this symbol. Okay, you have chosen the symbol lambda over here. So you can say that lambda is the symbol I have chosen for angle of friction. So how to find the value of lambda? Very simple. You can, by using the vector rule, you can draw this friction over here. Oh yo. So what we can do, I can draw the friction here. Okay, I've shifted this vector parallelly. So you can see that tan lambda, in this diagram, you can see tan lambda will be equals to, this is friction. Okay, friction upon normal. This is friction, this is normal. So in this diagram, you can very well see tan lambda will be equals to friction upon normal. Can you see that? Tan lambda will be equals to friction upon normal. Yes or no? So tan lambda will be equals to friction upon normal. So this lambda is called as angle of friction. Now if I ask you what can be the maximum value of lambda, think. You have to maximize lambda. Think. I'm asking what is the maximum value of lambda. Are very obvious na? When friction upon normal becomes maximum, that means when friction becomes maximum. So what can be the maximum value of Fr by n? When friction becomes mu n. What can be the maximum value of friction? Mu n. And we can say that tan lambda maximum value of this is mu s into normal divided by normal. Okay, friction ko I have written mu n. So that means lambda max will be equals to tan inverse mu s. Tan inverse mu s. So guys, what is the logic that you have understood from here? That maximum value of angle of friction can be tan inverse mu s. Maximum value of angle of friction can be tan inverse mu s. Hence, the maximum angle that you can get, between the reaction force and the normal reaction is tan inverse mu s. So it is a very nice concept actually, and there are very Olympiad level problems. Okay, like Olympiad level problems, like very difficult problems. Some of the very difficult problems can be solved using this particular concept. Okay, so this is a very nice concept which is used in mind-blowing problems. Lambda max is equals to tan inverse mu s. Okay, so I hope you have understood this. Lambda max will come out to be tan inverse mu s. Okay, so this is angle of friction. What is angle of friction? Angle of friction is the angle between the reaction force and the normal reaction. And what can be the maximum value of angle of friction? The maximum value can be tan inverse mu s again. Okay, do not confuse it with the repose. Angle of repose is different thing and angle of friction is different thing. Their values are equal. See, 2 into 2 is 4. 2 plus 2 is also 4. Does this mean that multiply and add, they are same? Of course not. Multiplying and adding are different operations. So similarly, angle of repose also comes out to be tan inverse mu s, and angle of friction also comes out to be tan inverse mu s. Does that mean that angle of friction or angle of repose is same? No, they are not same. I hope you have understood the logic. Okay, so this is angle of friction. Now we are going to talk about a particular thing called as two-block system. Many of the students are scared of this topic. There can be 3-block system, there can be 4-block system. So do not be scared of this topic. It's a very easy topic. What is two-block system? As you can see, block on block is called as two-block system. There are 2 blocks, block A, block B. One block is kept on top of the other. So this is called two-block system. So what will be 3-block system? Block on block on block. 3 blocks, one on the top of the other and other on, like last one on the highest point. So block on blocks, that is 3-block system. So that way, how can we have n-block system? Why not? N blocks, in n-block system you will have n blocks, and it will be like block on block on block on block, like this n times. So idea will be the same. Let's focus on 2-block system. So what kind of problems do we encounter in 2-block system? Very easy. Okay, there can be friction between these two surfaces, like that means between 2 blocks, or there can be friction between block A or the ground, or there can be friction between on the both the surfaces. That means here as well as here. Depending upon the question, you can have different situations. Okay, now force can be applied on block B. Suppose I apply a force like this on block B. Okay, I can apply like this, or we can apply the force on block A, or we can apply the force on both the blocks. That is also allowed. We can apply the force on block B in this direction, block A in this direction. Perfectly allowed. Okay, nobody is stopping you. Okay, so the questions are generally of this type, that what is the value of the force so that there is no motion? What is the value of the force so that both the block move together? This is one possibility. Okay, what is the value of the force so that both the blocks they slide on each other? So guys, effectively in 2-block system there can be 3 cases. There can be 3 cases. If you consider all possible problems of 2-block system, there can be 3 cases. First case, there is no motion whatsoever. That is block A doesn't move, block B doesn't move. That is the first case. That is no motion whatsoever. Second case is motion is there and there is no relative slipping. That means block B and block A, there is no relative slipping. That means here there is no, block B is not slipping on block A like this. Okay, can you see that? Remote is not slipping on my hand. So this is case 2. That means there is no relative slipping between block B and block A. Third case, there is relative slipping between block B and block A. So this is the case. Very simple. First case, there is no motion whatsoever. Second case, there is no relative slipping between block B and block A. Third case, there is relative slipping between block B and block A. Very, very simple. Okay. So in fact, you can say that first case is also the special case of second, because in first case, if there is no motion, in the first case there is no motion, that means block A is not moving, block B is not moving. So we can say that there is no relative slipping because there is no motion only. Block B is not moving, block A is not moving. That means block B is not slipping on block A. So you can think as if first case is the special case of case 2. Okay. But all in all, I have told you about 3 cases. There is no motion. Case 2 is there is no relative slipping. Block B and block A are moving, but they are not slipping on each other. Okay. Third case is that there is relative slipping between block B and block A. There is relative slipping between block B and block A. That means it might be the case that block A is at rest and block B is moving. It might be the case that both block A is moving, block B is moving, but with different accelerations. This is also allowed. Okay. So these are the possible cases. Do not worry about that. Only point that you need to think about in this question is the direction of friction. Why students face problem in this particular question, in this category of problem, is the direction of friction. What do I mean by this? I will explain with the help of a question only. Okay. So just remember my words. To find the direction of friction, assume friction to be absent. And now see the direction of relative slipping. Again, I will apply this. Please listen to me. I will apply this and you will understand. Trust me, you will understand. Just listen to me what I am saying. To find out the direction of friction, assume friction to be absent. To find out the direction of the friction, assume friction to be absent. Okay. Now see the direction of relative slipping. Now see the direction of relative slipping. Friction will oppose this. Friction will oppose this. Friction always opposes relative slipping. Okay. So what have I told you, my dear students? I have told you that always try to see the direction of friction. If you are able to find out the direction of friction correctly, your question will be solved. Okay. So what you have to do, assume friction to be absent. Now find the direction of relative slipping. Friction will oppose this. Now you might not have understood anything. Let's try to apply and understand the concept. Okay. Let's see the first question. Okay. Find the frictional force existing between the two blocks in the given figure. So here ground is smooth. Here this surface is smooth. Okay. This surface is smooth. Okay. And friction coefficient between these two blocks is 0.3. Friction coefficient between these two blocks is 0.3. That means between 2 kg and 4 kg, the friction coefficient is 0.3 and a 15 Newton force you can see is applied. Okay. Now will the motion happen? Of course, motion will happen because, you know, if you're applying, ground is smooth. So ground is smooth. That means blocks, it cannot happen that blocks can stay at rest. It is not possible simply. Okay. Now, we will always assume that there is no relative slipping. Listen to me very carefully. We will always assume that there is no relative slipping. Okay, we will always assume that there is no relative. We have discarded the case 1. That means, of course, motion is going to happen. Now, either case 2 is going to happen or case 3. In case 2, there is no relative slipping. Case 3, there is relative slipping. Okay, so we will assume that there is no relative slipping. We will assume that there is no relative slipping. That means 2 kg and 4 kg are going to go together. That means 2 kg and 4 kg are going to go together. Okay, so this is an assumption. We will check if this is true or not. Okay, so please try to listen to me carefully what I am saying. We will assume that you know, relative slipping is absent. That means 2 kg and 4 kg are going to go together. Okay, now we will check if this assumption is true or not later on. So first, if they are going to go together, so we can think of them as this type of system. Okay, this friction will become internal force. The friction between 2 kg and 4 kg will become internal force. Okay, so friction between 2 kg and 4 kg is going to become internal force. We have assumed that they both are going to go together. Okay, so it's a combined block of 6 kg. And what is the force acting, guys? 15 Newton. Force acting is 15 Newton. Yes. So what will be the acceleration? What will be the acceleration of this? Acceleration will be 15 by 6. That means 2.5 meter per second square, right? This is the value of the acceleration. So if there is no relative slipping, then both the blocks will accelerate by 2.5 meter per second square. If there is no relative slipping, then both the blocks are going to accelerate by 2.5 meter per second square. Okay, now let us check if there was relative slipping or not. Okay, so now look 2 kg and 4 kg in isolation. Now check 2 kg and 4 kg in isolation. So let us look at 2 kg. Okay, you can look at any of them. Let's look at 2 kg. Okay, so this is 2 kg. Okay, let's look at 2 kg. On 2 kg there is no force. We haven't applied any force on this. Okay, but there is friction between these two surfaces. Okay, now this is what I was saying. On 2 kg, in which direction friction will act? In which direction friction will act? Friction will act backward or forward? I mean, like towards right or left? So now think. Assume friction to be absent. Assume friction to be absent. So if there was no friction, then 4 kg would have simply moved forward. 2 kg would not have moved there. See, 2 kg, there was no force. Only force that can act on 2 kg is friction. On 2 kg, and if we are assuming there is no friction, that means 2 kg will simply stay at that point. 4 kg will simply move forward. Hence, relatively 2 kg is going backward and 4 kg is moving forward. What I am trying to say, please listen to me carefully. What I am saying is that with respect to 2 kg, 4 kg is moving forward. With respect to 4 kg, 2 kg is moving backward. Listen to me carefully, na? Arey bhai, 2 kg would not have moved if friction was not there. 2 kg would not have moved, right? 2 kg would have stayed simply there. 4 kg would have simply moved forward. Hence, with respect to 2 kg, 4 kg is moving forward. So friction will oppose this. So on 4 kg, friction will act backward. Hence, on 2 kg, friction will act forward. Again, I will repeat this. I assumed friction to be absent. I saw that 2 kg would have simply stayed over there and 4 kg would have moved forward. That means on 4 kg, friction will act backward and on 2 kg, friction will act forward. So we now understand that on 2 kg, the friction will act forward. Friction will act forward. Okay. Now, what have you said that? You have said that acceleration of the combined system is 2.5 meter per second square. Okay. How much? That means on 2 kg, only friction is acting. That means if we write the Newton's laws equation on 2 kg, what will you write? Friction will be is equals to mass into acceleration. That means this is 5 Newtons. Okay. Now you will have to check whether 5 Newtons was available or not. This is the friction that you have assumed is acting. Okay. Remember, we had assumed that there is no relative slipping. So we have to check that if this friction is available or not. We have assumed that this much friction is acting. If this much friction is available, that means our assumption is true. Because if this much friction is available, that means this much friction will be available for 2 kg. Okay, so it will be able to move with 2.5 meter per second square acceleration. But if this much friction is not available, then of course 2 kg cannot move with 2.5 and hence there will be relative slipping. So that is how we check relative slipping will happen or not. Okay, so guys, let us check how much friction is available. So here limiting value of the friction. Limiting value of the friction is how much? 0.3 into normal, coefficient of friction is 0.3. So 0.3 into normal reaction. And what is the normal reaction on this surface? Normal reaction on this surface is 20. Normal reaction on this surface is 20. So that means this becomes 6 Newton. So guys, how much friction is available? 6. How much we have assumed is acting? 5. That means this much is available. Hence, whatever we assumed was correct. That means there will be no relative slipping. That means this is the correct answer. Friction acting will be 5 and acceleration of both the blocks will be 2.5. So we were asked the friction force, the hence answer will be 5 Newton. I hope you have understood this. I will quickly again tell you what I have said. First, I saw that motion will happen. Then I assumed case 2, that means friction. I assume that both the blocks will move together. That means there is no relative slipping. So if both the blocks will move together, that means acceleration will be 15 upon total mass, which is 6. So acceleration comes out to be 2.5. Okay, now I will check whether the relative slipping will happen or not. The assumption that I have taken is actually true or not. So for that, I have looked 2 kg in isolation. I have to looked 2 kg. I have analyzed 2 kg in separation. Okay, separately. So on 2 kg, only one force could have been present, which was friction. Okay, normal and mg will act in y-axis, but along the x-axis only friction is present. Okay, now what is the direction of friction on 2 kg? So assume friction to be absent. So if friction is not present, then 2 kg cannot move, whereas 4 kg will move forward. So with respect to 2 kg, 4 kg is moving forward. Hence the acceleration of hence the friction on 4 kg will act backward, and on 2 kg will act forward by third law. So friction will act on the 2 kg in the forward direction. So I wrote the Newton's law equation on 2 kg. Friction will be equals to 2 into A. So acceleration was 2.5. Hence friction is 5 Newton. But this friction is 5 Newton if there is no relative slipping. So we will check. That means this is the assumed value of friction. That means we have assumed this much friction is acting. This much friction can act only if this much is available. So we checked how much friction is available. So 6 Newton was available. Hence we can say that this much friction will be able to act. So our assumption was correct that there will be no relative slipping, and the acceleration of both the blocks will be 2.5 and friction will be 5 Newton. I hope guys you have understood. Let us see one better question than this. This is a nice question. Okay, I will suggest all of you to try this on your own once. This is a very nice question. A system of 2 blocks shown in the figure. So you can see top block is 5 and bottom block is 10 kg. The coefficient of friction between 10 kg and the ground is 0.4. Okay, and between both the blocks is 0.6. So here the coefficient of friction is 0.6. Here the coefficient of friction is 0.4. That means friction is present on both the surfaces. Okay, we have to find. So this force is 80 Newton is fixed. You can see that this 80 Newton force is fixed. We are applying force F and we have to find the maximum value of F so that it does not slide. 5 kg and 10 kg does not slide. That means we want motion to happen but relative slipping to be absent. That means we are talking about case 2. Okay, the most famous case, the maximum question you will find is about case 2 only, when the motion happens but there is no relative slipping. So that is the most famous case. Okay, so that means what do we want? We want that motion to happen but there should not be any relative slipping. Okay, because if we apply force F, if we keep on increasing the force F, then of course the friction from the ground, mixed friction from the ground will not be able to match. Okay, and motion might happen, but we do not want relative slipping to happen. Okay, now please try to understand. So guys, we assume that both the blocks move together. So if both the blocks move together, what kind of system will you see? So that means this kind of system, right? We are assuming that both the blocks are behaving as a common system. That means this is 15 kg. Okay, this friction will become internal. This friction will become internal force. So it will not come in force diagram. Okay, what is the normal reaction here? Normal reaction here is N1 or right N2. N2 will be equals to 15 into 10, that means 150 Newton. Okay, N2 is equals to 150 Newton. And what is the normal reaction here? N1 will be equals to 50 Newton. Okay, so let me draw this slightly down. So guys, now see, so I'm assuming this as a single system. That means this is a 15 kg block. We can think of this as a 15 kg block, right? And this friction FR1, friction 1, which will be between 5 kg and 10 kg, will be internal force. So it will not come into picture. Okay, and this friction, so I'm assuming that block is moving. So basically this friction will be kinetic and this friction will be FR2, which will be equals to FR2 will be equals to how much? 0.4 into 150, that means 60. Okay, so how much force is acting on this combined 15 kg? Friction 2 is acting in the backward direction, 1F is acting here and 180 is acting here. Okay, so that means what will you write? F plus 80 minus friction 2, which is 60. That will be equals to mass into acceleration. So mass will be equals to 15 into A. Okay, this is the value of A we do not know as of now. So this will become 15A plus 20 minus 20. Okay, so this is the value of F. Okay, so we have written this equation assuming that both the blocks move together. Okay, now again try to see 5 kg in isolation. So let me show you 5 kg in isolation. Okay, this is how 5 kg looks. This is how 5, in fact let me show you this by different color so that things look slightly beautiful. Okay, so which color should I choose? Yellow color. Okay, so you can see that this is how 5 kg looks. Okay, on 5 kg one force of 80 Newton is acting. Okay, now apart from this there will be friction acting on 5 kg because of the friction between the 5 and 10 kg. This is now an external force because we are just considering 5 kg. That means this friction will become external force. Okay, now what will be direction of friction? So now please try to assume this friction was absent. Assume this friction was absent. Okay, so this friction was not there. So 5 kg would have moved by an acceleration of 80 by 5. This friction is not there. So 5 kg will simply move 80 by 5. That means 16 meter per second square. And 10 kg will move by value F. So what is the force on 10 kg? F and friction 2. Okay, this friction we are assuming to be absent. So 10 F and friction 2. Now there is no limit on F. Who is applying F? We are applying F and we have to maximize F. So we can keep on increasing F. Increase. That means 10 kg can move with infinite acceleration. Okay, if the friction is not present. So we can keep on increasing F. That means 10 kg can have very large acceleration. So with respect to 5 kg, 10 kg is going to move forward. Hence on 10 kg friction will act backward. Which friction? Friction 1. Friction 1 will act backward. So by third law on the 5 kg friction 1 will act forward. I hope you have understood this. Okay, again I will repeat guys. Assume friction 1 to be absent. So 5 kg will move with an acceleration of 80 by 5, which is 16 meter per second square. But 10 kg can move with large acceleration because F can have any value. F needs to be maximized. Therefore 10 kg can have very large acceleration. Hence with respect to 5 kg, 10 kg will move forward. So on 10 kg friction will act backward. Friction 1 will act backward. So on 5 kg friction 1 will act forward by third law. Okay, now remember our aim was to maximize F. Hence A needs to be maximum. Also there should not be any relative slipping. Hence whatever is the value of A, that A should also be of this value. That means 5 kg should also move with that acceleration because both 5 and 10 are moving with the same acceleration because there is no relative slipping. But if you see 5 kg in isolation, so it should be able to move with acceleration A. Okay, now ideally we would want A to be very high, but if you look carefully, write the force equation on 5 kg. So you will see that 5 into A, that should be is equals to FR1 plus 80. Right, now you want A to be as high as possible because if you maximize A, then F will be maximum. But FR1 has a certain highest possible value. FR1 cannot increase beyond F but for a certain value. So what is the maximum value of FR1? So maximum value of FR1 is FR1 limiting, which will be is equals to how much? 15 to 0.6. So 30. So FR1 cannot go beyond 30. Do you understand this? FR1 cannot go beyond 30. So this maximum can be 30 only. So that means what can be the maximum value of A? So that relative slipping is not happening. So that will be 110 upon 5. That means 22. So maximum acceleration of both the blocks so that there is no relative slipping is 22 meter per second square. Okay. Now you can put this 22 over here. So if you put this 22 over here, what value you are going to get? So this will become 22 into 15. So that means 330 minus 20. So that means this will become 310. 310 Newton. Option D will be correct. I hope you have understood this, guys. I hope you have gotcha. Righto. So guys, this was two block system. Practice lots and lots of question on two block system. Remember the ideas that I have told you. Okay, direction of friction is important. Remember the cases that I have told you. Okay, you should not face any problem. So guys, that's all from my side. thank you. I hope you would have enjoyed the one shot. I will be taking lots and lots of questions, PYQs on friction, so that you develop the application part. Okay, so that your application part is improved. This was the theory part. So guys, that's it from my side. Thank you. See you. Bye bye. Love you.